Hello everyone and welcome to my CompTIA A+ 1101 video series. In this video we will start reviewing Domain 2, which covers basic networking. For Objective 2.1 we are going to look at TCP/IP, the difference between TCP and UDP, and all of the ports and protocols you need to know for the exam. If you missed all of Domain 1 and the videos that go with it, don't worry, I have all of them linked in the description below. There's a lot to cover here, so let's go ahead and get started. Before we dive into all of this content, let's discuss exactly what ports and protocols are. Networking protocols and human languages are alike in several ways. Just like human languages provide all of us the ability to communicate and understand each other, networking protocols facilitate communication between devices connected to a network. Both networking protocols and human languages have rules that govern how information is transmitted and understood. Also, just as different human languages exist to serve different purposes and contexts, various networking protocols are designed to support different types of communication and tasks within a network. While many have come and gone over the years, TCP/IP is the one protocol suite that has survived. Let's take a look at TCP/IP, which stands for Transmission Control Protocol, Internet Protocol. It is a foundational protocol suite used for communication over the internet and most local networks. It provides a set of rules that govern how data is transmitted and received between devices. TCP, or Transmission Control Protocol, ensures that data packets are delivered reliably and in the correct order, while IP, or Internet Protocol, handles the addressing and routing of the data packets across all of those networks. TCP/IP is basically a lot like the languages that devices use to communicate with each other on a network, ensuring that data is sent and received accurately and efficiently. At first, this may seem overwhelming, so let's take a look at the TCP/IP structure. The DoD model, also known as the Department of Defense model, is an early networking model that served as the basis for the development of the modern TCP/IP protocol suite. It was created by the U.S. Department of Defense to guide the design of strong interconnected computer networks. The DoD model consists of 4 layers: the application layer, the transport layer, the internet layer, and the network access layer. Each of these layers map to the 7 layers of the OSI model. More on that coming up. So let's quickly review each layer of the DoD model. Let's begin with the application layer. This layer corresponds to the application layer in the OSI model and is responsible for providing network services directly to user applications. It includes protocols for tasks such as email, file transfers, and remote access. The transport layer, also known as the host-to-host layer, is where the Transmission Control Protocol (TCP) and User Datagram Protocol (UDP) reside. TCP ensures reliable, connection-oriented communication by sequencing and acknowledging data packets, while UDP provides connectionless, unreliable transport for applications that can tolerate some data loss. We'll take a look at these two protocols in more detail coming up. The Internet layer is equivalent to the OSI model's network layer and is where the Internet Protocol, or IP, operates. IP handles the addressing and routing of packets between different networks, allowing data to travel between multiple network segments to reach its destination. Last is the network access layer, which includes all of the lower layers of the OSI model, data link and physical layers, and deals with the physical transmission of data over the network medium. It includes protocols for defining how data is formatted for transmission and how the devices access the network. The Process Application Layer Protocol is a crucial component of the DoD model and is responsible for providing end-to-end communication services for applications. This layer, which is the 7th and topmost layer of the OSI model, facilitates interaction between software applications and lower layer network services to ensure data is properly formatted and understood by the receiving device. Key protocols within this layer include HTTP, Hypertext Transfer Protocol, for web browsing, FTP, or File Transfer Protocol, for file transfers, and then SMTP, Simple Mail Transfer Protocol, obviously for email services, and DNS, Domain Name System, for resolving domain names into IP addresses. These protocols handle data encoding, encryption, session management, and error detection, ensuring that the communication between applications is seamless, secure, and reliable. By abstracting the complexities of the underlying network layers, the application layer enables developers to focus on building user-focused features and services. Think of port numbers in networking as an apartment number within a large building. The building itself is like an IP address, which identifies the entire structure in a specific location, much like how an IP address identifies a device on a network. Each apartment within the building has a unique number, giving visitors or guiding visitors to the right door. Likewise, port numbers direct data packets to the correct application or service within a device. Just as you need both the building address and the apartment number to visit a friend, a computer needs both the IP address and the port number to correctly route network traffic. Let's take a look at the protocols and the ports that are listed for this objective and the A+ exam in order by port number. File Transfer Protocol, or FTP, is a standardized network protocol used for transferring files, uploading and downloading from one host to another over a TCP-based network such as the Internet. FTP operates on two ports. Port 20 is used for data transfer and port 21 is used for control information. When a file transfer is initiated, the FTP client connects to the FTP server on port 21 to establish a control connection. Then a data connection is set up on port 20 for transferring the actual files. FTP is commonly used to upload files to a website or download files from a server. The negative to FTP is that it's unsecure. As it transfers the data, any usernames and passwords included are shown in plain text. Secure Shell, or SSH, is a network protocol that provides a secure way to access and manage a remote computer or a server. It encrypts the data transmitted over the network, providing confidentiality and integrity of the communication. SSH uses port 22 by default for establishing secure connections between the client and the server. Unlike FTP, which transmits data in plain text, SSH encrypts the information, making it a more secure option for remote access and file transfers. Telnet is a network protocol that allows users to remotely access and manage other devices on a network. It provides a text-based interface for communication with a remote device. Telnet operates on port 23 by default. Unlike SSH, Telnet does not encrypt the data sent over the network, which can pose security risks as information is transmitted in plain text. It is recommended to use SSH instead of Telnet for secure remote access and management of devices. Simple Mail Transfer Protocol, or SMTP, is a standard protocol used for sending and receiving email messages across networks. SMTP operates on port 25 by default. When an email is sent, the SMTP client connects to the SMTP server on port 25 to send the message. The SMTP server then processes the message and forwards it to the recipient's email server for delivery. SMTP is a text-based protocol that works in conjunction with other protocols like POP3 and IMAP for receiving emails. The Domain Name System, or DNS, is an administrative naming system for computers, services, and other resources connected to the Internet or private network. It translates domain names such as thetechrated.com into IP addresses, which are numerical identifiers used to locate resources on a network. DNS helps users easily access websites and services by typing in a human-readable domain name instead of having to remember a complicated IP address. I wouldn't necessarily say complicated, but imagine trying to remember every IP address for every website that you go to. The DNS operates over the Internet using Transmission Control Protocol, or TCP, and User Datagram Protocol, UDP, on port 53. Port 53 is the default port used for DNS queries and responses. When a device needs to resolve a domain name to an IP address, it sends a DNS query to a DNS server on port 53, which then provides the corresponding IP address in response. Dynamic Host Configuration Protocol, or DHCP, is a network protocol that automatically assigns IP addresses and other network configuration settings to devices on a network. DHCP operates on port 67 for the server side and port 68 for the client side. By using DHCP, network administrators can centrally manage and allocate IP addresses to devices, simplifying network administration tasks. Unless you have a reason to assign a computer a specific IP address, then it's always going to be better to let DHCP do that for you. Trivial File Transfer Protocol, or TFTP, is a simple protocol used for transferring files between devices on a network. It is a lightweight version of the File Transfer Protocol, or FTP, and is commonly used for transferring configuration files and boot files and other small files that the network administrators may need. When a file transfer is initiated, the TFTP client connects to the TFTP server on port 69 to send or receive the files. TFTP does not require user authentication and has limited error recovery mechanisms compared to FTP. Hypertext Transfer Protocol is a protocol used for transmitting data over the Internet. It is the foundation of data communication in the World Wide Web. HTTP functions as the request-response protocol between a client and the server, where the client makes requests for resources such as a web page, images, videos, music, whatever the request is. That's the point of the server, and it responds with that content. HTTP operates on port 80 by default. When a client sends an HTTP request to a server, it does so over port 80. The server, in turn, responds to the request over that same port. This port number allows the client and the server to establish a connection and communicate effectively. Post Office Protocol, or POP, is a protocol used for retrieving emails from the mail server. POP typically operates on port 110 for unencrypted connections and port 995 when encrypted. Post Office Protocol allows users to download emails from the server to their local devices for offline access. The Internet Message Access Protocol, or IMAP, is a protocol used for retrieving email messages from a mail server. It enables email clients to access their email messages stored on that server. IMAP allows users to view and change their emails without actually downloading them to their local device. When an email client connects to a mail server using IMAP, it does so over port 143. This port serves as the communication endpoint for the IMAP protocol, controlling the exchange of email data between the client and the server. Now that we have covered both IMAP and POP email protocols, let's get past all of the technical jargon and actually discuss what are the differences between the two. First up, IMAP allows users to access and manage emails directly from a mail server. This means that they are synchronized across multiple devices, allowing users to access the same emails on different devices. IMAP stores those emails on the mail servers, so users can access their complete mailbox from any device with an internet connection. IMAP is ideal for users who need to access their emails from multiple devices and locations. On the other hand, POP is completely different. POP downloads emails from the mail server to the user's device. Emails are typically stored locally on the device, and users can only access the emails from the specific device. POP is a one-way communication protocol, meaning that actions taken on one device will not be reflected on the other devices. Basically, what happens there is if you open an email and then read it on one device, you may be able to open that same email on another device and it still show that it is unread. POP is suitable for users who primarily access their emails from a single device and do not need to synchronize emails across multiple devices. NetBIOS stands for Network Input and Output System and is a networking protocol used for communication between devices on a local area network. NetBIOS provides services for naming, session establishment, and datagram transfers. NetBIOS typically uses ports 137, 138, and 139. 138 will be used for the datagram service, 139 will be used for the session service. These ports are used for various NetBIOS functions such as a name registration and resolution, connectionless communication, and connection-oriented communication. Simple Network Management Protocol, or SNMP, is a protocol used for managing and monitoring network devices and their functions. SNMP operates on port 161 for its standard version. It also allows network administrators to collect information about devices, monitor their performance, and configure settings remotely. The Lightweight Directory Access Protocol, or LDAP, is a protocol used for accessing and managing directory services over an IP network. It enables clients to query and update information in a directory service, which can include user accounts, groups, and other network resources. LDAP operates on TCP port 389 by default for non-secure communication. HTTPS stands for Hypertext Transfer Protocol Secure. It is an extension of HTTP and is used to secure communication over a computer network, typically the Internet. HTTPS encrypts the data exchanged between a web browser and a website, providing a secure connection that helps protect sensitive information such as login credentials, financial transactions, and personal details from being intercepted. The default port for HTTPS is 443. This port is used by web browsers to establish a secure connection with the web servers that have SSL and TLS certificates installed. When a user accesses a website over HTTPS, the communication between their browser and the web server is encrypted. The Server Message Block, or SMB protocol, is a network file sharing protocol that allows applications and users to access files, printers, and other resources on a network. SMB operates on port 445 for its standard version. Our last protocol for Objective 2.1 is Remote Desktop Protocol, or RDP. It is a proprietary protocol developed by Microsoft that allows users to connect to and control a remote computer over a network connection. It enables remote access to desktops, applications, and other resources on a remote machine. The default port used by Remote Desktop Protocol is TCP port 3389. This port is used for establishing the connection between the client and the remote desktop server. It is essential for enabling the remote desktop access and control. As we move on to the transport layer protocols, let's discuss TCP and UDP in more detail. Transmission Control Protocol, or TCP, is a connection-based protocol. It will use HTTPS and SSH. This is a connection-oriented communication protocol that allows computing devices and applications to send data via network and verify its delivery, playing a very important role in the global internet. An example of TCP in action is when you stream a video from an online service like Netflix. When you press play, your device sends a request to Netflix's servers to start the video stream. This request and the video data basically are transmitted using TCP. TCP manages the data packets to ensure that they arrive in order and without errors. If any packets are lost or corrupted during the transmission, TCP requests that those packets are retransmitted and making sure that everything receives a continuous and accurate video stream. This reliability is crucial for maintaining the quality of the service and the user experience in data-intensive applications like video streaming. User Datagram Protocol UDP, on the other hand, is a connectionless protocol. For example, it is used by DHCP and TFTP. It is a message-oriented communication protocol that allows computing devices and applications to send data via network without verifying its delivery. Since UDP does not require acknowledgement of receipt and does not perform error checking or retransmission, it allows for faster data transmission. This is useful in live broadcasts, online gaming, or voice over internet protocol phone calls, where occasional data loss is less noticeable and the emphasis is on maintaining a smooth experience. The internet layer includes 4 protocols. Let's take a look at each one. First up is the Internet Protocol, or IP. As I just mentioned, it is a set of rules for routing and addressing packets of data so they can travel across multiple networks and arrive at the correct destination. An example of IP would be an IP address, which is a unique 32-bit number that identifies a device on the internet. IP addresses are usually written in dotted notation, such as 192.168.123.132 with 4 numbers separated by periods. Each number represents 8 bits and 1 octet. There are 4 octets in an IP address. Next is the Internet Control Message Protocol, ICMP. It is used for reporting errors and performing network diagnostics. In the error reporting process, ICMP sends messages from the receiver to the sender when data does not come through as it should. Then we have Address Resolution Protocol, or ARP. It connects a constantly changing Internet Protocol or IP address to a fixed physical machine address, also known as the Media Access Control or MAC address, in a local area network. Last is Reverse Address Resolution Protocol, or reverse ARP. This is a protocol a physical machine in a local area network can use to request its IP address. It does this by sending the device's physical address to a specialized reverse ARP server that is on the same LAN and is actively listening for reverse ARP requests. The network access layer, also known as the link layer on the network interface layer, is the foundational layer in the DoD Department of Defense model, which is more commonly known as the TCP/IP model. This layer is responsible for the physical delivery of data over a network. It encompasses all of the hardware and protocols necessary for the physical transmission of data, including network interface cards, cables, switches, and the media access control protocols. It ensures that the data packets are correctly formatted for transmission and handles error detection and correction. Essentially, the network access layer allows devices to connect to and communicate over a network, providing the means for data to travel from one device to another within a local network segment before reaching higher layers for further processing. This completes Objective 2.1. I realize that we just covered a lot of content. However, it is important to keep in mind that for the A+ exam, you need to have the basic understanding of TCP/IP. You need to know the difference between TCP, which is a connection protocol that ensures delivery of data, and UDP, a connectionless protocol that does not ensure the delivery of data. Also, you need to know all of the protocols and ports mentioned here. If you have any questions or comments, concerns about this objective, go ahead and leave them in the comments below and I'll do my best to answer them. Thank you for watching the video, and I will see you in Objective 2.2.